We have just learned how to find the least squared regression line when we have data. Sometimes we don't have raw data, however, and we only have descriptive statistics, meaning we only have the mean and standard deviation of each set of data. So this video will show you how to create the least squared regression line if we don't have data but just descriptive statistics. So we have two different formulas that we will use, and it's important to understand what goes into each formula. So first we're going to find the slope. Remember the slope was b1, b sub 1. And notice to find the slope I'm going to take r, and remember r was my correlation coefficient, and make sure that you include the sign on whatever r is. So if r is negative, that's going to make our slope negative. Remember that is why it's negative. If r is positive, it will make our slope positive. These two values are the standard deviation of y and standard deviation of x, which of course makes perfect sense because this is the average change in y, and this is the change in x. And if you remember our slope formula, that is what we did when we subtracted y2 minus y1 to find the change. Then we're going to find our y-intercept. Our y-intercept, or b sub 0, is by taking y bar. Remember, this is the mean of our y values, and whatever y is would be our response variable. And then we're going to take b1, which is our slope, multiplied by the mean of the x variable, which is our explanatory variable. So in our last video, we were given a bunch of data, and we used that data in StatCrunch to create the least squared regression line equation that looks like this, and that is in the proper form with the hat over fair and everything. Now what I want to do, and again, number 1 says list your response variables. We've already done this. In our last video, we said that the fair would depend on the distance, so the distance would be x and the fair would be y. But now from here, I'm just going to use the summary statistics given to me, and I'm just going to plug them into the equations that I have copied at the top of the screen because I don't expect you to have them memorized already. And keep in mind that s sub y, s sub x, that's the standard deviation. So this is my sx, this is my sy. The r is my correlation. So even if it doesn't say r equals, we know that that's the correlation. And the other equation requires me to use y bar and x bar, and so that means the mean. So this would be the mean of my x values, and this would be the mean of my y values. So now that I have everything labeled appropriately, I'm going to find the slope, and the slope would be found, again, just using this formula. And the slope is b sub 1, and we're going to use our correlation of 0.694 multiplied by the fraction of my standard deviations, so 56.37 divided by 497.8. So that's how we would set that up, and that's what I have again here. Notice when I multiply that out, which of course I did using a calculator, I find a slope of 0.079, and it makes me very happy because that is the same value I found before. Then I would go on to find my y-intercept, and my y-intercept is b sub 0. I would start by taking my y bar, or the mean of my y values, 244.33. And I'm going to subtract my slope, 0.079, multiplied by the x bar, which is the mean of my x's, or 853.7. And notice when I do that, I get not quite the same answer. So some people might be confused or concerned, but remember I said it's always preferable if I have data to use that data. Why is this one not quite as precise? Because all of these values in the table are all rounded, and so I'm using rounded data to find my equation. So the fact that it's not exactly the same Doesn't concern me. It would concern me if it was very, very far from what I had found using data. So again, now I have my slope and my y-intercept. I'm going to put them all together in the correct format, which is of course using the variable names and the hat over the y variable. So I'm saying fair hat equals 176.89 plus 0.079 times distance. So I have one of those for you to try as well. Notice on this one, I don't know what the equation is supposed to be ahead of time. I'm given some information, and the first thing I have to do, and of course the most important, is to determine which one should be x and which one should be y. I'm going to leave that to you. So press pause, do all 4 of the questions, and then press play to see how you did. So in the question itself, it says, I'm trying to find the price of a house if I know the house size. So based on that right there, I'm going to determine that this is X and this is Y. And if it doesn't give me that sentence, I would still look at this and say, gosh, the price of a house would probably depend on the size of a house. So notice what I've done is I've given this to you in the wrong order, and therefore it's up to you to make sure you know which one is supposed to be which. So it might be a good idea if you tend to get confused easily or just want to make sure you're covering your bases, that I know that this is the mean and this is my y, so this is y bar equals, because that's the mean of my y's, x bar equals the mean of my x's. Standard deviation, this would be s sub y, the standard deviation of my y's. This would be s sub x, standard deviation of my x's. Correlation is always r. So just make sure you're not assuming I've given them to you in the right order, because I'm not always nice, as everyone knows. So list the explanatory and response variable. I've already done that. X is house size, Y is house price. Now I'm going to find the slope. And again, the slope would be found using this first formula, which would of course be 0.085 times 86.64 over 0.6. And again, this would be very, very different if I did the x and the y in the wrong order. So that's why that first step is the most important. But now I have found my slope. The y-intercept uses that slope of 122.74. And it's going to take 200, which is the mean of my y's, as indicated here, times the slope, or minus the slope times the mean of my x's. Again, I'm getting all values from here in my table, and I get a slope of 9.51, which means my regression equation is house price, hat, remember the y always has the hat, the x never does. I'm not predicting x, I'm predicting the house price based on x, equals 9.51, which is the y-intercept, which comes first, plus the slope times x, which is house size.